Hello. Thank you very, very much, Peter and organizers for making this online event happen. My name is Hiroya Tanaka from Keio University, Japan. Today, my presentation title is from 4D Sprinting to Contextual 4D Design. Actually, this is my fourth time to attend 4D and Metamaterial conference because this conference is my favorite. In last couple of years, I introduced my original software for G-code editing and simulation, and also design examples. In my laboratory, students are working as research collaborators for me, and almost every student has at least one 3D printers at home. And also, we are working with large material companies in Japan. They are making very unique filament, like shape memory polymer and some reactive filament and so on. Last year, I introduced our 4D sprinting-based design framework. The first layer is functional materials. The second layer is geometric structure. The third layer is environmental stimuli. By combining three of important factors in very artistic way, we can realize very beautiful and organic movements. And there would be lots of future applications in various fields. So this year, we'd like to focus on user-centered design thinking method. As you may know, design students have very good skills for drawing future scenario and the future lifestyle and life scene with novel technologies like 4D sprinting. So here, I'd like to pass the baton to two of my excellent students, Mizuki and Keisuke. They're going to talk about their research project.
Hello, I'm Mizuki Mori, and I'm a fourth-year student at Keio University.
Hello, I'm Keisuke Saito. I'm a second-year student at Keio University.
What I am showing here is a clip from the movie Back to the Future 2, where the main character puts on a pair of sneakers with power laces. As you can see, the sneakers he's wearing do not require bending over or actual tying. The shoe just laces itself automatically. These self-lacing shoes are portrayed as shoes of the future, an item that will make our lives more convenient. But if we look at it from a different point of view, these self-lacing shoes can also act as a helpful tool that solves someone's problem. Japan is currently one of the most rapidly aging societies in the world, and according to 2019 estimates, about 28% of the population is 65 years old or above. Senior citizens tend to stay home and do not go outside very often, and we believe that one of the reasons is because it is difficult for them to change shoes. Putting on and taking off shoes require bending over, and this is not easy for many seniors who have weak muscles and bones. Frequent bending over can also cause back pain and aches, and avoiding this can lead to more issues, such as lack of exercise and social withdrawal. Going outside can improve overall health, and if shoes are able to be worn automatically with functions to loosen or tighten itself to conform to the wearer's foot, this can encourage many people to go outside more often. Why Japanese people even take off shoes in the first place lies in our cultural background. Japanese developed this custom to avoid bringing mud and dirt from outside because most houses were made with tatami flooring, which is extremely hard to clean dirt from. Japanese are also accustomed to do daily activities on this tatami floor, such as eating and sleeping. What you see here are photos of traditional Japanese entrances for a house, apartment, hospital, hotel, nearly any building in Japan. This is called genkan in Japanese and is a place for people to remove their outdoor shoes and change into indoor slippers. These are past works done by our lab members. We believe that these social issues can be solved with 4D printing, a technology referred to as 3D printing that uses special materials and sophisticated designs that can change structure post-production by reacting to environmental parameters. This feature allows 4D printed products to adapt to their surrounding environment, thus improving people's daily lives. We call these environment-responsive products situation-adaptive products. Our goal is to propose new normals and lifestyles with situation-adaptive products to adapt to our constantly changing society and improve people's daily lives. The shapes these situation-adaptive products change into depend greatly on the situation they are used in. So it is significant to take both technology and application into consideration when designing. There is not much prior research on environment-responsive products, but they are starting to gather attention in various fields, such as architecture, fashion, and food. For example, HygroSkin is a climate-responsive architecture with apertures that open and close autonomously in response to humidity changes from 30 to 90% and adjust themselves accordingly. The apertures are made from thin modular plywood sheets with meteor-sensitive receptors and do not consume any energy nor use mechanical or electronic control. On dry sunny days, the apertures remain closed, still letting light inside through thin slits of closed plywood. On rainy days, the apertures open fully to let light inside. Biologic is a responsive bioskin with natto cells as actuators that expand and contract according to atmospheric moisture, enabling the biological skin self-transform when the bacteria is activated. The synthetic bioskin reacts to body heat and sweat, causing flaps to open, enabling sweat to evaporate and let the body cool down naturally. These are the materials and equipment we use for our works. FFF 3D printers such as Ender 5, stretchable fabric, and special polyester called thermoreactive filament that has shape memory functions. This special polyester softens at around 45 degrees Celsius and solidifies when it is cooled down, and can be softened and reshaped easily post-production by using a hairdryer or putting it in warm water. This special polyester can be printed out using typical FFF 3D printers. With these equipment and materials, we created 3 types of situation-adaptive shoes. 1. Pop-up shoes. 2. Foldable shoes. And 3. Shape memory shoelace. Each shoe proposes a new normal or solution to social issues we face today. The first one is pop-up shoes. Inspired by the sneakers from Back to the Future 2, these pop-up shoes self-assemble from a flat surface and do not require bending down to put on. These are designed to overcome barriers and motivate people to go outside. Cloth tension and several types of special polyester with different temperature ranges is used to control the shape and movements of the shoe. Second, we have foldable shoes that propose a post-pandemic new normal. These are designed to be collapsible shoes that you can carry in bags because we assume that the demand for such shoes will increase due to the 3 following reasons. 1, because domestic travel will increase as people avoid traveling abroad. 2, because hotels will refrain from offering slippers for public use. And 3, because guests will refuse to use public slippers. Many public facilities in Japan, including Japanese-style inns, usually offer slippers for guests to put on while they stay at the hotel. But due to the impacts of COVID-19, it is expected that this tradition will change. Shoes tend to be too bulky to carry around, but this is solved by making the shoe foldable and compact. Special polyester that softens at a certain temperature is used for insoles and enables users to fold and unfold the shoe when it is exposed to heat. As shown in the movie, the shoe opens autonomously when it is heated. A third example of our 4D printed shoes is a pair of children's shoes that can grow with the user. A child's foot grows in no time, and parents may need to buy a new pair of shoes before the previous one is even worn out. To ease this household economic issue, we designed a shoe that enables one to adjust the shoe partially to a desired shape or size to fit the user's foot. The patterns are based on kirigami, which is Japanese paper art that includes cutting. Like the other 2 pairs of shoes shown previously, this shoe also uses special polyester and opens and closes when it's exposed to heat. Here is a short movie that shows how all 3 pairs of shoes work. On the other hand, 4D printing still faces problems. Most 4D printing operations are unidirectional and lacks both reversibility and reproducibility, which requires one to reshape the object manually after every operation for the object to return to its original form. For example, the pop-up shoes can rise from a flat surface, but cannot return to its flat state on its own. The foldable shoes can unfold itself, but needs someone to fold it first. The shape memory shoelace can close autonomously, but needs someone to open the slits manually.
The challenge for us now is to change the shape and return it to its original shape without using our hands depending on the situation. By realizing bidirectional movements in 4D printing, repetitive operations can be performed as well as eliminating the need of manual configuration and reducing time and labor to the minimum. There are two forces that make these movements work: cross tension and magnetism. The front side of the object is 3D printed with iron-filled metal composite PLA, and the back is printed with PLA using a 3D pen. Using the existing case studies of 3D printing on fabric as differences, we created an arbitrary shape due to the tension of the fabric. By imparting heat and magnetic force to the object, the power balance between the magnetic force and the cross tension changes, resulting the object to shape shift. The shape is fixed by PLA on the back, which has a log glass transition point of 35 degrees Celsius. However, this method of bidirectional 4D printing still faces problems. First, durability, difficult to repeat deformation. Second, balance of power, difficult to control the balance between cross tension and magnetic force. If we can overcome these challenges and achieve bidirectional 4D printing, we can create products that can change their shape according to the situation. It has the potential to solve society's problem or create new lifestyles. We are trying to create a shoes that stands up when you go out through the front door and flatten out when you come back to your home. This lowers the hurdle of going out of the elderly who have difficulty bending over in an aging Japanese society. This is just one example of upgrading the pop-up shoes. We plan to continue our research and development on bidirectional 4D printing and achieve our goal to propose new normals and lifestyles with situation-adaptive products to adapt to our constantly changing society.